Let's discuss a problem from engineering mechanics, basically from the statics part. So a pulley system is given, and we need to find out how much P is required to lift the mass. So this is a problem of static equilibrium. Basically, if you can provide the value of P such that you can just keep 100 kg mass stationary, and that will be the minimum P which would be able to lift the mass, because just an incremental increase in that P would raise the 100 kg mass. So we are supposed to find out the P which maintains 100 kg in equilibrium. So for these kind of problems, you have to understand one major thing. A single cable, which is this a single cable, when you have the tension remains same across, the tension remains same, the tension remains same on the cable. Okay, if it is a single cable, on a single cable, if you have frictionless pulleys, so that is the assumption here, frictionless pulleys. Now if you have friction, then probably you have difference of tension across the pulleys. Like if you have a friction here between the pulley and the rope or the cable, you will have one of the side you will have a Tmax and the Tmean, something which you would study in the design of brakes. But here, as it is stated that there is no frictionless, there is no friction between the pulley and the rope. So we have the tension is same on the cable throughout. Okay, so here what we do is we take the bottom pulley first. Okay, so we take the bottom pulley and we draw the free body diagram. Let me draw it here itself. So the bottom pulley will have a tension. Assume that in this cable, which is a single cable, T is the tension. So here T is the tension, and here also T is the tension, and here also T is the tension, because it's a single cable and there is no friction. So for the bottom pulley, the forces are T and T across both the sides, and this 100 kg, which is mg, that is 100 into g, and g has to be taken as 10, so it is 1000, right? 1000 newtons. So this is for the bottom pulley. Okay, and for the top pulley, the free body diagram would be, well, this is the tension. Remember, the signs of the tension is always away from the pulley, because a cable can always support a tension. It cannot support, it will slack if it supports a compression. So tension, when you draw the free body diagram of bottom pulley, the tension will be always away. For that matter, any pulley, the tension, the rope is always away from the body. Okay, as it can, it's a tension actually, it's a pulling force, it's not a pushing force. Okay, and this is also T, but you need to apply the same P in order to, okay, and there is also a top, because it is connected, so that might be something else which is not required and not desired in this problem. Okay, so basically from the top pulley you will understand that the force required is basically T. This is from the top pulley diagram. From the bottom pulley, if you are able to find out T, now it's in equilibrium, so sigma vertical forces is 0. So 2T, that is T plus T upward, minus 1000 is equal to 0. So T is equal to 500 newtons, and that if I substitute it here, I'll get P is equal to 500 newtons. So this is basically a mechanical advantage problem. You can lift a 1000 newton weight with the force of 500 newtons. So it is mechanical. Pulleys are, that's why, used for mechanical advantage problem. So this is the learning we have. Answer is B. Thank you.